Okay, here are your equations.
Yeah.
Now, this is different from physics
What?
because these are parametric equations. Okay? As you're writing them down, let's talk about what these funny symbols are. What's the V? Okay, V sub 0, we also call it V naught. Initial velocity. All right. Now, well, T, what is T? Okay, time. Now, you'll have to read the problem to determine what units your time is in. Same with velocity. What is that H naught going to stand for?
Height.
Which height? Initial height. Anytime you see that sub-0 or not, okay, that's talking about when time is 0, aka initial. Oops. Okay. Now, we're talking about parametric equations, right? I have an equation for x and I have an equation for y. Um, um, X is going to tell us what about our projectile? So horizontal distance, very good. Y is going to tell us what about our projectile? The vertical distance. So basically, X is going to represent how far are we from the starting place, okay, along the ground. Y is going to represent how high off the ground we are, okay? Now, if we start above the ground, this H naught, that's taking care of it, all right? So Y is representing how high we are off the ground. Okay. Now, what kind of an equation do we have here for Y? What kind of an equation is that? A quadratic. So you will have to remember a couple things about quadratic equations. Okay. This will be the only portion of your test where you will be allowed a calculator. So go ahead and get that out, please. Oh, where's my calculator? Okay. So first of all, I'm going to tell you that we're going to have to be working in degrees. So what I need you to do is go to your mode, and I want you to put it in degree mode. Now I'm also going to show you just how you would graph one of these on a calculator. So go ahead and just put it into parametric mode as well for me. Okay. If you tried your homework last night, it's already in parametric and degree mode. Okay. So, here is the problem we are going to work with. A football is kicked with an upward velocity of 30 feet per second at an angle of 55 degrees. Okay? So consider the position of the ball at any time t, and we're not going to worry about air resistance affecting the ball. It's not windy. Right? Okay? So, first of all, let's set up our equation. Okay, so this is what I want you to do. What's our equation for x, the general equation? X equals what? Okay. So V naught is 30 feet per second is our initial velocity, right? And our angle, okay, so we have 30 times, I just want you to write cosine of 55 degrees t. I don't want you to approximate it. So I want you to write. Okay? And then y is negative 16t squared plus v naught sine of our angle t plus the initial height. What is the initial height? 0. That makes it nice. Okay. I want you to leave it as the cosine 55 and the sine 55. It'll help with your accuracy later on when we have to use those. Okay. Now, just for fun, we're going to graph these. Whoops. That's not it. Y equals. Whew, okay. Okay, when you go to y equals, notice how you have an x equals and y equals. Pretty. Okay, so x is 30 cosine of 55, close your parentheses, and where you usually click x, or where you click your theta, when you click it, it is now t. Yes, sir. Go to mode, and it's the PAR, next to the function. Okay, and then our y is negative 16t squared plus 30 sine of 55, close your parentheses, t. If you were to guess what kind of graph this is, what do you think it's going to be? A parabola. Error.
I didn't get quoting or moving. Mine doesn't do that. Mine doesn't go all the way down. Yeah, mine starts with the X.
It's probably because of your window. Oh, yours doesn't go all the way down. If you go to window, then your T minimum is probably set at 0, which we would want, right? That would make sense. So yours looks like that.
Oh, there.
So this is representing the half of our football. Okay? Yes. Are you closing your parentheses?
Yes.
Do you have any plus on? Are you in degrees? Okay. So let's move on. Okay? You're not going to have to graph these. I just wanted to show you how to graph them on your calculator because we're working with them. You might as well know.
You change it to the X1 line. That's where you put it in.
That's putting into parametric mode. Okay? All right, so I want to know when the ball will hit the ground.
Oh, that's when y equals 0.
Okay, first of all, we are talking about a vertical height. Okay? Height indicates vertical, which indicates we're using our y equation. What is the height at the ground? So we want our y to equal 0. Okay? Let's do some algebra. What do you notice about this equation? On the right side. You can factor out a t. Beautiful. So we're going to factor out a t. So we're left with negative 16t plus 30 sine of 55 degrees. Now, I have a product that equals 0. So either t equals 0, that makes sense because that's where it starts, okay? Or t equals negative 6, or 0 equals negative 16t plus 30 sine of 55. So we have to do. Okay, subtract this over and then divide by that
Add the
16.
16.
Okay, or you could just say, all right, we're taking 30 sine of 55, correct? And doing what?
Fine. We could do that, but then that would be
The easy way out.
yeah, that's the easy way out.
Okay. What do we get?
5.5359.
Okay, we're on to 3 decimal places. 1.536. And what is our unit? Okay, you should always get 2 answers because it's a quadratic. Please go with the answer that makes sense. We know this first answer is where we began, t equals 0. Obviously, that's not what we want. Okay, it's going to take 1.536 seconds. Okay, football people, what do you call this? Hang time. Okay? You don't need to know that. Okay?
Feedback.
Now, if we had an initial height, we would have plus a constant here. What would be your method of choice to solve that quadratic?
Oh, I would do the simplification of the
Quadratic formula?
Yep.
Okay, with these numbers, you would want to use the quadratic formula if you had an initial height. If you don't have an initial height, then you have 2 terms, both with a t, so you can factor it out. Okay?
Plus or minus the square root.
We'll talk about it in a little bit. I'll remind you. All right, so we're still working with the same kick of the football. I want to know how far the ball travels in the horizontal direction. I see the word horizontal, which means we're going to work with which equation? X. However, how do I know what to plug in for t?
1 point. Oh, I can see that part.
Okay, 1.536 was how long our football was in the air. Okay, so that is going to tell us, well, that's how long it took to hit the ground. So that's how long it was in the air. So that's the time we are going to use. Yes, sir.
So theoretically, you can find the zeros on your calculator and get all this information.
I want to see algebra.
Theoretically.
Theoretically, yes, but I want to see the algebra. I want to see all this work. Okay? It is a great question, but I do want to see your work. So, okay, now this is what I want you to do with your calculator. Okay? You do not clear this out. Okay?
Right.
So x is 30 times the cosine of 55 times 1.536 to get an accurate answer. Just push second answer and it's going to bring that back up. Oh, shoot. I didn't look at it. 26.429. And what is our label? Okay, this is in feet. How many feet are in a yard? 3. So take this times 3. That's how many yards it goes. It's like 80 yards.
Yeah. 5 by 3. Conversions.
Oh,
It's like
yes, you're right.
Kick that straight up in the air and have it come like right down.
Okay, Yeah, maybe this was an onside kick.
Charlie Brown.
But it still wouldn't have been a good onside kick because that's your opinion. Okay.
You
It's
got
also
some
just one
knowledge.
point. That's it. Yeah, it wasn't that, but it was not.
Okay, so
That was like.
we do not want this kicker doing our onside kicks. All right. At what time will the ball reach its maximum height?
I got that out for you.
The vertex. Okay? Now, I heard somebody else say the total time divided by 2. Okay? The vertex will work for you every single time. Why is it okay to cut our total time in half?
Because it's our rabbit.
That's not why.
It starts at 0.
It starts at 0 and ends at 0. If that is the case, it is okay to cut our total time in half. However, if that is not the case, which most of the time I'm going to tell you it's probably not going to be, then we need to look at the vertex. So let's talk about how we used to find the vertex back in our Algebra 2 days.
Calculate.
Oh, well, you could. I don't know.
It's a formula with an A and a B. What? Has to deal with the quadratic a little bit.
I remember this.
B and an A.
Oh, that's just the. I don't need that.
The x coordinate for our vertex is always at negative b over 2a. Seems like some of us need to write this down to remember it. Okay?
What is this?
This is the x coordinate of the vertex of our parabola. Okay? Now, what we have the equation y equals negative 16t squared plus 30 sine 55 degrees t, okay, plus 0. All right, so instead of an x, we have a t. That does not make a difference. But we're going to say negative b. What's our b value? 30 sine of 55 over 2 times a is, okay. So if we take 30, negative 30, times the sine of 55, and we divide it by negative 32, we get 0.768. Which is the same as if we would cut our total time in half because we have symmetry in where we start and stop. Okay. Yes. Because our to find the vertex, it's negative b over 2a. Okay, that's something you need to remember. All right. Now, if you are cutting your total time in half, I still want you to go to your calculator and cut the entire number in half. I don't think the TI-86s, you guys can like actually arrow up and highlight that, right? Okay. Next year I'll have a TI-86 up here. I know, it'll be nice.
How do you do this in first place?
Magic. All right, now, lastly, find the maximum height of the football.
Use the time.
Use the time and plug it into which one?
Of y.
Okay, height, we're plugging into y. So this is when we reach the maximum height. So let's plug that time in to our maximum height.
the answer is going to be something along the lines of 9.3607.
What is it?
Somewhere in there.
9.436071. Just in case you're confused.
So why is the height?
Yes.
Okay, 9 feet.
Okay, now I need to talk about something.
9 feet. That's incredible.
Okay. You have 5 problems. Now I want you to look at the first problem. The first problem gives you a situation about a baseball being hit from home plate. And it gives you information about how far and how tall the fence is that he's hitting it in that direction. Okay? And they want to know if it will be a home run. Okay? What are you going to have to find? How are you going to figure out if this person hits a home run?
You have to figure out what is height was at 400 feet.
Yeah, what's the height at?
And how far is that? 20 feet.
Okay, now 400 is our X or horizontal distance, thank you. So if you figure out the time that it is 400 feet, the height better be bigger than 20. If you figure out the time that your height is 20 feet, it better be, okay, it better be 400 or more.
Yep.
Okay? So you can go one way or the other, but your argument needs to be legitimate. Okay?